Welcome, ladies and gentlemen. So what I'd like to do is show you how to determine the horizontal asymptotes of a rational function. So basically, remember, the vertical asymptotes of a rational function is basically when the denominator is set equal to 0. So to find the vertical asymptotes, pretty basic. You just take your denominator, set equal to 0, solve by factoring, whatever else. And whatever those values are, that's going to be your asymptotes. Obviously, if it also can be factored out, it can create a whole. Horizontal asymptotes are fairly simple as well, but they do take a little bit more ingenuity to determine what they're going to be. So what we have is the horizontal asymptote test. And basically, for any rational function, that's why I call it r of x, you have a function in the numerator, which is n of x, and a function in the denominator. Why did I write q? That doesn't make any sense. The denominator, which will be d of x. So I'm going to erase all these q's and write d of x. Okay, so basically I have a function in the numerator and a function in the denominator. And so basically the the horizontal asymptote test says when you're looking at the degree, remember the largest power of your polynomial in descending order, right, the highest one. When you're looking at degree, if n of x is greater than d of x, then there's no horizontal asymptote. You're actually going to have a slant or an oblique, which I'll get into later. When the degree of your numerator of your n of x is less than d of x, therefore your horizontal asymptote is going to be y equals 0. And when your degree of n of x, remember n of x represents the function in the numerator and d of x represents the function in the denominator. When the degrees are exactly the same, then you have y equals a over b, where a and b represent the leading coefficients of each function. So let's go ahead and take a look at this one. So what I'm going to do is if I don't have a degree noted, I'm going to use a marker here to label them. So in the degree in my numerator is 1, and the degree in my denominator is 2. So basically, what I'm going to have is 1 and 2. Well, obviously, 1 is less than 2. So my numerator, degree of my numerator, degree of my denominator. So 1 is less than 2. My horizontal asymptote is y equals 0. Now remember, vertical asymptotes was x equals, right? Because that creates vertical lines. Horizontal is going to be y equals, because that creates horizontal lines. Did I say horizontal twice? I don't know. All right, so now, again, we have our degree in our numerator and degree in our denominator. So we basically just do 2 is equal, or 2 and 2. So I'd have n of x, d of x, right? Kind of create a little table. And obviously, those are equal. So since they're equal, we're going to take the coefficients, the leading coefficients of our numerator and our denominator. So we can say a is going to equal 8, and b is equal to 4. So y equals a over b, which is equal to 8 over 4, which is equal to 2. In this example here, you can see my degree of my numerator is 3, and the degree of my denominator is 2. Obviously, 3 is larger than 2, so therefore, n of x is greater than d of x. So therefore, there's no horizontal asymptote. In this example here, I don't have the powers written, so it's 1 and 1. So obviously, you can say that 1 is equal to 1. So we're going to say that's a and that's b. Remember, a and b represent the leading coefficients of each of your functions. So therefore, I have y equals a negative 3 over 8. Okay. One important thing that we didn't really get into, some very crazy problems with this. But just remember, when you are determining degree and leading coefficients, make sure that your polynomials are in descending order. And I kept it pretty simple for you. But you might encounter a problem where you'd have to write it in descending order first and then determine the degree and leading coefficient. So I just want to kind of make you aware of that. But besides that, it's pretty basic. Once you kind of use the process over time, you'll pretty get used to everything. Kind of have it memorized. But I wanted to write it up there for you so you had everything down pat. Thanks.